So we'll be starting off with algebra. That's our next chapter in the sequence. So what is algebra all about? Algebra is all about having variables and finding their solutions or finding their values. Okay. So what do we actually do in algebra? We have multiple equations which come up. What do we mean by equations? We have an equation whenever we find the sign of equal to somewhere and there is a variable also involved. The variable can be multiple in number. They can be 1, they can be 2, they can be 3. Okay, so this is monomial, this is binomial, and this is trinomial and polynomial. So it can be multiple variables. So there is a very standard point which I want all of you to know. The standard point is that the number of equations has to be equal to the number of variables. When this situation comes up, only then and then you can find out the solution of the variables or the value of the variables. There is another connect to it which comes like it's an extended portion of it. There is a possibility that the number of equations there is a possibility that the number of equations is much higher or higher than the number of variables. When this situation comes up, so all the extra equations might be of use to us, might not be of use to us. Let's assume that there are 3 variables and there are 4 equations. So such a question is definitely solvable. Why? Because one of the equations might lead to a more precise solution. Okay. Had it been 3 equations and 3 equations and 3 variables, it is the perfect setting. Okay, it is a perfect setting. But if the number of equations is more than the number of variables, it is also completely fine. You'll still be able to find out the solution for each and every variable. Okay, so in order to solve one or two or more equations, we must know two techniques. Okay, we must know two techniques. One is that of substitution and the other one is that of elimination. In substitution, in the concept of substitution, what happens is that we have to, I'll just show you two equations. Okay, let's assume that the value of x plus y is equal to 7. Okay, let's assume that the value of x plus y is equal to 7 and the value of x minus y is equal to 3. I hope you will be able to quickly find out that the value of x here must be 5 and the value of y here must be 2. That is when 5 plus 2 is equal to 7 and that is when 5 minus 2 is equal to 3. So you could do it verbally because it's pretty evident and the numbers which were involved were very small. Okay, 7 and 3. These are small numbers. It's easier to calculate them. So when we are trying to solve it with the help of substitution method, when we are trying to solve it by substitution method, okay, substitution method, that is when we use, let's assume this is the first equation and we assume this to be the second equation. At that point in the first equation itself, we put in the values of one variable from the second equation. Okay, we use the values of one variable from the second equation. Let's assume that the value of, like, again from the question itself, the value of x plus y is equal to 7. Now from the second equation, I'll quickly pull up the value of x being equal to 3 plus y. This is a derived form. This is a derived from form out of the x is equal to 3 plus y equation. Okay, so this is a derived form from the second equation. In such a situation, when x is equal to 3 plus y, I'll put the value of x back into the first equation. When I put the value of x back into the first equation, I get 3 plus y being equal to 7. I have 2 y's over here and the 3 would go here and create a 4. So 2y is equal to 4. So the value of y is equal to 2. I take this back, put it here, and I get the value of x being equal to 5. So this is the substitution method. Substitution methods are good for numbers which are smaller in nature, or the digits which we have, they are smaller in nature. It's easier to solve them. But I like to follow the elimination method. Okay, I like to follow the elimination method. What happens in the elimination method? It is that you keep two equations together, x plus y being equal to 7 and x minus y being equal to 3. When you have these two equations together, you quietly perform an operation between the two equations. You quietly perform an operation between the two equations. What is the operation which I can apply between the two equations so that I can eliminate one of the variables out of it? Here I can see that if I add y and minus y together, the output would come out to be 0, which is the elimination of y, right? So if I quietly do an addition operation in both the operations, I get the value 2x, y got cancelled out, is equal to 10. Here I can declare that the value of x is equal to 5. When I take it back to the first equation, I get the value of y being equal to 2. Okay, so the elimination method is, according to me, is a little simple. It's simpler than the substitution method. Substitution method is definitely valid, definitely doable. Elimination is equally well, but I personally prefer elimination method to be working better for me. Okay, good enough. Let me quickly move to the first question that we have here. What are the values of x and y? What are the values of x and y where 6x plus 7y is equal to 5xy? Okay, I'll quietly write it down. Uh, when I say quietly, I also mean quickly. So do not get confused. 6x plus 7y is equal to 5xy, and 10y minus 4x is equal to 4xy. In multiple equations, you will find out that the number of variables, these are two variables and these are two equations. This is definitely solvable, but there is a very small problem. The very small problem is the is the variable x and y. Both the variables are multiplied with each other and they become a third kind of a variable. Variables, till the time they are being added or subtracted, it's not a problem. As soon as the variables are multiplied or divided with each other, they create a new variable. So in such a situation, I would first have to very like tactically take away xy from the equation and then solve it. Firstly, I would take out xy from the equation and then solve the two equations. And secondly, there is another point. Secondly, there is another point. So we have an equation over here, two equations over here, and out of the two equations, I'll quickly write them down first. I have 6x plus 7y being equal to 5xy, and 10y minus 4x is equal to 4xy. This is the first equation and this is the second equation. We have learned in the previous slide that the number of equations should be equal to or greater than the number of variables. We have two equations over here and we also have two variables. The only problem which I see in this equation is that the xy, the variables which are getting multiplied, they can produce a third variable. So to avoid that, I need to break up the relationship of multiplication between x and y. Why am I doing that? The reason is that even if I solve the two equations by manipulating the values of things on the right hand side, I would only be able to get a relationship between x and y. It will be difficult for me to reach the absolute values of x and y. Also, it would lead to a quadratic equation, which are a little difficult to solve as compared to these linear equations. Okay, so these are two linear equations which I have. I'll try to remove the values of xy from the equation. How would I do that? I would divide it by x and y on both the sides for both the equations. So I would end up getting 6 upon y plus 7 upon x being equal to 5, and 10 upon x minus 4 upon y being equal to 4. So in such a situation, the equation needs to have variables on the numerator side. Okay, Why is that so? Because again, the same problem. The equation can lead to a quadratic equation when I would try to solve it using the substitution method. But if I solve it using the elimination method, I might get the right answer, but I would not try that. What I would do, I would quickly write down that 1 upon y is equal to a, or let's say 1 upon y is equal to b, and 1 upon x is equal to a. When I have made these assumptions, I would rewrite the equations. How would I do that? I would write 6b plus 7a being equal to 5 and 10a minus 4b being equal to 4. Now, these two equations, which are our new equations, I would call this equation A and equation B. So let's call it equation alpha and equation beta, because we would ultimately get confused. We already have the variables which are A and B. So it's better to call it alpha and beta. I'll now try to make the coefficients the of the variable b same. So I would multiply the first equation with 4 and the second equation with 6. That would lead to 60a minus 24b being equal to 24. This is the second equation, or the beta equation. Then 24b plus 28a being equal to 20. Okay, to eliminate the value of b, or to eliminate the variable b, I would quickly add both the equations. This would lead to 88a being equal to 44. From here I can assume, or I can deduce the value of a being equal to half. I'll take the same value of a being equal to half in the second equation, or in the beta equation. How would I do that? I know that the value of 10a minus 4b is equal to 4. A being equal to half, I can say that 5 minus 4b is equal to 4. From here, I can get the value of b being equal to 1 by 4. When I have my two major values of a and b, I can go back to the assumptions which I made. Okay, these were the assumptions which I made. The assumptions say that 1 upon x is equal to a, so the value of x is equal to 2, and 1 upon y is equal to b, so the value of y is equal to 4. So I have two values, 2 and 4. Okay, good enough, sorted enough. Let me take things forward. Now, I have three variables, I have three equations. This means it is definitely solvable. I'll write them down. X plus y being equal to 8, y plus z being equal to 13, and z plus x being equal to 17. Now, if I can reach a point where I can find out the values of all of them separately, then I can easily tell the value of x square upon y into z. Yep. So I'll do that. I would introduce a basic trick for you over here. If I add the left hand sides of all the equations and the right hand sides of all the equations, I would reach a point where I can say that twice of x plus y plus z is equal to 38. Okay, twice of x plus y plus z is equal to 38. From here I can come to the conclusion that x plus y plus z is equal to 19. Right, now I have the sum of all of them as 19. For every equation there is a variable missing in that equation. If I talk about the first equation, the variable missing is z. If I talk about the second equation, the variable missing is x. And if I talk about the third equation, the variable missing is y. Okay, so the if I do a simple difference between 19 and 8, the value comes out to be 11. Similarly, 19 and 13, the value comes out to be 6. And 19 and 17, the value comes out to be 2. 19 and 17, the value comes out to be 2. So this is how I achieve the values of all the variables in a single shot. Okay, every time there is a three equation three variable concept, this is the first thing that you're supposed to do. Find out the sum of all the variables by adding up all the equations together. Once that is achieved, then you can do the hide and seek method. What does the hide and seek method mean? In the first equation, the missing variable is z. So that means if I do a simple operation of x plus y plus z, of x plus y plus z minus x plus y, this would give me my variable z, which was missing in the first equation. Okay, so that is what I have done. This is the expanded form. This is the expanded form of the operations which I have conducted over here. This is a hash sign and this is a hash sign. So we'll be able to achieve the value of z through the equation which doesn't have z in it. Good enough. Now I have the values of x, y, and z. What do I need to do now? I need to quickly find out the value of x square upon yz. What does x square stand for? 6 into 6. What does y and z stand for? Y stands for 2 and z stands for 11. 2 ones are 2 threes are. My final value comes out to be 18 upon 11. Okay, and that is what I was looking for. Let's move on. Two numbers are in the ratio of 5 and 3, and the difference between these two numbers is 34. Find the smaller of the two numbers. If two numbers are in the ratio of 5 and 3, I can assume that the first number is x and the second number is y. So the ratio of x and y is 5 is to 3. If I try to find out the difference between the two, I can say that the value of 5, like when they are equated together, they are 5y is to 3x, right? The difference between the two is 34. The difference between the two is 34. There is a small glitch that has occurred. This wouldn't be the case. If the value of x is related to 5 in such a manner that the value of y is related to 3, that means if I introduce a variable between them, I can say that x is equal to 5a and y is equal to 3a. The gap between 5a minus 3a is equal to 34, which is also the gap between x minus y, which is also the gap between x minus y. This means the value of 2a is equal to 34 and the value of a is equal to 17. The value of a is equal to 17. So when I use the value of a is equal to 17 back to the equation, I can say that the value of x and y are 17 threes are 51 and 17 fives are 85. 17 threes are 51 and 17 fives are 85. So when I have 51 in my position, this is the answer which I was looking for. We could have done this in a shorter format as well. The shorter format would have said that 5 is to 3 is the ratio between the two numbers. The gap of the ratios is equal to 2. The 2 in absolute terms is equal to 34. That means the value of 1 in absolute terms is equal to 17. With the value of 1 is 17, it's asking me for the smaller number. The smaller number is 3. So the value of 3 is 13, 17 threes are 51, which is the answer which I was looking for. Okay, this is the shortcut that I was looking for. All right, let's move on. Okay, by the following basic rules of exponents and powers, expressions can be simplified in this manner. So what are we basically talking about? We are talking about surds and indices. Surds and indices. This is this is one of the most standard forms that we talk about. How do we talk about it? We talk about a variable which has been given a power of a. Okay, this is a variable. What do I mean to say? I mean to say that x now would be multiplied by itself for the number of times n, and the value of n would be equal to the value of a. For any simple variable, let's assume when I say x raised to the power 1, that means x is going to be multiplied with nothing, with only 1, or itself. It should have only 1 of itself. When I say x raised to the power 3, that means x has to be multiplied with itself 3 times. But whenever I have a situation where raised to the power 1 is multiplied with x raised to the power 3, when the bases are same and there is a multiplication sign, then the powers are added. This would lead to x raised to the power 4. This is the most simple rule that I'm talking about. Okay. So when there is a multiplication sign, the powers are added. When there is a division operation, the powers are subtracted. Whenever there is an inverse operation, the power takes the negative sign. Okay. The power takes a negative sign whenever there is an inverse operation. Anything raised to the power 0 is equal to 1. Anything raised to the power 1 is equal to itself. When two variables, two different variables have common powers, they can be multiplied first and then the common power can be given to them. Okay, again, when two different variables are divided and they have a common power, let's assume that of a, when they have the same power, then they can be divided first and then the power or then the exponent can be raised up. Okay, so also, if you need to destroy the exponent or you need to bring down the exponent to the power of 1, at that time you have to take roots on both sides. If I take a root of k on the left hand side and x raised to the power k, this would give me a root of k on the y side as well, on the right hand side as well. This k would get cancelled over here and I can easily say that the value of x is equal to y root k. Okay, y root k, or I can also call it y raised to the power 1 upon k. Okay, k can be anything. It can be a 2, it can be a 3, it can be a square root, it can be a cube root. Okay, I hope most of you must be knowing about it, but for the ones who don't know about it, these are the simple rules that we follow, right? So move on. Let's move on. Hmm. So I have this equation. This is a triple equation. Okay, this is a triple equation, and we have to find out what is the value of 1 by x plus 1 by y minus 1 upon z. Okay, 1 by x plus 1 by y minus 1 upon z. So 2 raised to the power x is equal to 3 raised to the power y. No, there is this fault. 3 raised to the power y and 3 raised to the power y and 6 raised to the power z. Now, if these three are together, I cannot do much about it. I just know that 2 multiplied by 3 is equal to 6, and that is the only place where I can find out a relationship. So, what do I do about it? I quietly give the value of k. Okay, I quietly give the value of k to all these variables together. That means 2 raised to the power x is also equal to k, 3 raised to the power y is also equal to k, and 6 raised to the power z is also equal to k. When I say 2 raised to the power x is equal to k, I say that 2k is equal to k raised to the power like 1 by x. Similarly, the value of 3 is equal to k raised to the power 1 by y. And similarly, 6 is equal to k raised to the power 1 by z. Okay, 2, 3, and 6. I have all these options with me. When I multiply 2 into 3, I get the value 6. So I'll quickly write it down like 2 multiplied by 3 is equal to 6. I'll pick up these values from here and I would say that k raised to the power 1 by x multiplied by k raised to the power 1 by y is equal to k raised to the power 1 by z. As all the bases are equal, as we have common bases over here, I can say that k raised to the power, when both of them are being multiplied, k raised to the power 1 by x plus 1 by y is equal to k raised to the power 1 by z. So if I have 1 by x plus 1 by y and I have 1 upon z on the other side, as the bases are same, I can conclude that 1 upon x plus 1 upon y is equal to 1 upon z. Can this be concluded, yes or no? The answer is yes. So the question asked me, what is the value of 1 plus 1 by x plus 1 by y minus 1 by z? And my answer to that is minus 1 upon z. My answer to that is 0. Okay. So the final answer is 0. I hope it is very much clear. Good enough. Let's move on. This is the same question. Okay. This is the same question which we did there. And no, this is a little different. This is a little different. Let me quickly solve it. Why did I mark the answer in so much confidence? Huh? Overconfident math. So 6 raised to the power x is equal to 3 raised to the power y is equal to 2 raised to the power z. Okay, the value is equal to k. This means k raised to the power 1 by x is equal to 6. K raised to the power 1 by y is equal to 3. And k raised to the power 1 by z is equal to 2. So when I multiply y and when I add these up, 1 upon y multiplied by k raised to the power 1 by z is equal to k raised to the power 1 by x. So 1 by x is equal to 1 by y plus 1 by z. The question being asked is the same, 1 upon y minus 1 upon or plus 1 upon z minus 1 upon x is equal to 0. So this 0 was something that I was talking about. All right, good enough. Moving on. Now, there is something called zeros of polynomials. So, what is the main motive for us to study algebra? The main motive is to find out the values of each variable. Okay, our main motive is to find out the values of each variable. When I say the value or the equation of a variable px is defined as x plus 3. Now I need to find out the value of x in this equation. So what do? We try to put that px is equal to 0, and then I solve it for 0, that the value of x plus 3 is equal to 0 and the value of x is equal to minus 3. This is where the question ends, but there is a further step. When I write p raised to the p in the bracket minus 3 and I write x plus 3, this x needs to be replaced with minus 3. Minus 3 plus 3 is equal to 0. So I can say that minus 3 is the 0 of px. I hope you're able to understand the function. I hope you're able to understand the function over here. So minus 3 is the 0 of px. Now the value of minus 3 whenever applied back to px, will lead to the solution of the equation and it would give us 0 in it. Okay, I hope you're able to understand whatever I'm talking about. So minus 3 is the 0, or minus 3 is also the solution of the equation. So in such polynomials, whenever we have the degree to be 1, the number of solutions would also be equal to 1. Similarly, for 2, the minus 3 is also called the root of the equation. Okay, this was one important important concept, that whatever are the zeros, the solutions, they are also called the roots. So the number of solutions are 1 for 1, degree 1. For degree 2, the number of solutions are going to be 2, and for degree 3 and so on, the number of solutions is going to be equal to the degree of the polynomial. What do I mean by the degree of the polynomial? Let's say that there is a polynomial x raised to the power 3, x raised to the power 2 plus x raised to the power 1 plus 1 being equal to 0. This means the highest polynomial exponent, the highest polynomial exponent that we have, which is equal to 3. This is the degree of the polynomial. Good enough. Let's move on. Okay, check whether the polynomial this is a multiple of 2x plus 1. In such a situation, what do? We've written about it over here on the left hand side. Yeah, there are two ways of doing it. There is a long division method as well, which we used to do in school, but I would not recommend you to do that because there is a shorter way. There is a shorter way of dealing with it. This is the polynomial px that we're talking about. It has been asked that, let's assume this is qx. Let's assume this is qx. Qx is equal to 2x plus 1. Whatever would be the roots of qx would also automatically become the roots of px. If that actually becomes the roots of px and it solves down to 0, that means qx plus a qx is a multiple of px. Okay, qx is a multiple of px when the roots or the zeros of qx match with that of px. So instead of finding out the zeros for this form of equation, it's easier to find out the zero of this form of equation. How do I find that out? I'll do it quickly in a jiffy. 2x plus 1 being equal to 0 here, and 2x is equal to minus 1, and the value of x is equal to minus half. X is equal to minus half. Okay, I hope that is understood. X is equal to minus 1 by 2. When I have this value of minus 1 by 2, I would put it back in px and try to find out if my equation is getting satisfied. 4 has to be multiplied. I'm just putting in the values of x that I found out in the form of qx. Okay, so 4 would be multiplied by minus 1 by 2 raised to the power 3 plus 4 multiplied by minus 1 by 2 raised to the power 2, and minus, there would be minus 1 by 2 minus 1. Okay, everything is in place. Minus 1 by 2 when it is cubed, minus 1 by 2 whenever it is cubed, it comes out to be 4 upon 8. Yeah, minus 1 by 2 when cubed becomes 1 by 8, and the minus sign comes back because in square it gets like gone, it gets cancelled out. In the cube it remains, or any odd power would remain a negative sign, and any even power, even being negative, it would come out to be a positive sign. Okay, so minus 4 by 8 plus 4 upon 4, this negative sign has been has gone away. This minus minus becomes plus, that is 1 by 2, and there is a minus 1 over here. When I solve it, I get minus 1 by 2 plus 1 by 2 minus 1. Everything gets cancelled out, and whatever I am left with is 0. Okay, whatever I am left with is 0. I hope you're able to understand this. Whatever I am left with is equal to 0. Happy enough? Good enough? Let's move on. Examine whether x plus 2, just a second. So the question was, check whether the polynomial is a multiple of 2x plus 1. If the final answer has come out to be 0, and which was also like minus 1 by 2 was also a root of qx, and it also became a root of px, that means yes, 4x cube plus 4x square minus x minus 1 is a multiple of 2x plus 1. Okay, this is the declaration, this is the agreement that we've reached upon. Now, examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. So I'll have to first find out the zeros for x plus 2. I'll put it equal to 0. The value of x comes down to be minus 2. This minus 2, I'll quickly put it back here. Minus 2 raised to the power 3 plus 3 minus 2 raised to the power 2 plus 5 minus 2 being here alone plus 6. So minus 2 raised to the power 3 becomes minus 8. Minus 2 square becomes 4. 4 into 3 is 12. So this is 12. And this becomes minus 10. This becomes 6. So 12 plus 6 is 18 and 10 plus 8 is 18. Both of them are opposite in signs and the final output is 0. So yes, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. All right, pretty much sorted. Everything is in place. I'll move on. Factorize 6x square plus 17x plus 5. So I would like to introduce you to a concept of middle term splitting. Okay, which is very much explained over here as well as over here, but I will try to explain it to you in my words first, and then I would take you to the bookish definitions. See, what happens in middle term splitting is that this 17 is something that is the bone of contention. If you're able to split it down, which also leads to us the power or the degree of this quadratic equation, which is equal to 2. That means in the end there would be two solutions. Okay, there would be two solutions in the end. So I need to split down 17 in such a manner that I'm able to factorize the polynomial and I can bring out two equations which multiply each other and create 6x square plus 17 plus 5. Okay, 6x square plus 17x plus 5 needs to be created. Okay, it needs to be created. So what do? I find out the product of zeros and the sum of zeros. See, in the product of zeros, I need to multiply. Let me introduce the standard form here. Ax square plus bx plus c. So the product of zeros is equal to a multiplied by c, and the sum of zeros is equal to b. So when I multiply a with c according to this equation, I get the value of 30. And when I put down the value of b, which is equal to 17. Now I need to find out the multiples. I need to find out the multiples which get multiplied, or the factors which get multiplied and produce a sum of 17. If I do that, there is 1 comma 30, there is 2 comma 15, there is 3 comma 10, there is 5 comma 6. Is there anything else? 6 comma 5, that is the same thing. So I can clearly see that when 15 is multiplied with 2, we get a 30, and when 15 is added to 2, we get a 17. So 15 plus 2 is a 17. Okay, 15 plus 2 is a 17. I hope you get it straight. I hope you get it well, right? 15 plus 2 is 17. So how do I actually break it down now? I get the value of 6x square plus 15x plus 2x plus 5. Now you need to form pairs of this. You need to form pairs of this. How would you do that? You would do that by taking things common. I have 3x common here in the first two pairs. What do I write next? 2x plus 5. And I have a 1 common over here because there is nothing common between 2x and 5. So this is 2x plus 5, which leads me to a point where I can multiply 2x plus 5 and multiply 3x plus 1. So in this manner, I have factorized down the polynomial of degree 2. If somebody asks me what can be the probable values of x, I can say that the value of x is equal to 5 by 2 minus 5 by 2 in the first case and minus 1 by 3 in the second case. So x can take up two values. In the previous slides, I talked about the number of solutions being equal to the degree of the polynomial. So here it is proved that the degree of polynomial was 2 and the number of solutions which came out were also 2. Good enough? I'll move on. Okay. Write a quadratic equation whose zeros are 5 and -3. Now, in this manner, I'm supposed to go in a reverse order. What I can actually do about it is I can quickly write down that if the zeros of x is equal to 5 and the zeros of the other x is equal to -3, I can say that x minus 5 is equal to 0 and x plus 3 is equal to 0. When I multiply these two equations together, I can say that x minus 5 and x plus 3 both are going to be 0. I can say that x square minus 2x minus 15 is equal to 0, right? So this was my answer. This was what I created out of it. Now, if you see very clearly, the coefficient of x, the coefficient of x is the sum of roots, and the constant term, and the constant term is equal to the product of roots. So that is what we are able to achieve out of it. Okay, that is what we are able to achieve out of it. If you need to find out, or if you need to write down the equation in such a manner, then you already have the zeros of a quadratic equation. A plus a is ax square plus bx plus c is equal to 0. Then the sum of roots which I have here, let's say alpha plus beta, these are the sum of roots, which is equal to 5 and -3. This would be equal to 2. This is equal to minus b upon a, and alpha into beta, which is equal to 3 minus 3 into 5. This would come out to be minus 15, which is equal to c upon a. Okay, when I would have b upon a and c upon a to my rescue, I can write that x square minus alpha plus beta, which is equal to b upon a, it's equal to 2x and minus 15. This would come out to be 0. Okay, this would come out to be 0. I hope that is clear. I hope this is very, very clear. Yep, good enough. Let's move on. Find the roots if they exist. Okay, find the roots if they exist. There is a concept called determinant. In any quadratic equation which is of the form ax square plus bx plus c being equal to 0, in any standard form of equation of quadratic formula ax square plus bx plus c being equal to 0, there is something called d. D is basically the determinant, which is b square minus 4ac. The value of d, or the value of the determinant, helps in determining if there are roots of this equation or not. Okay, if the determinant is negative, if the determinant is negative, there are no real roots. If the determinant is positive, then I have two distinct roots. If I have the determinant which is equal to 0, then I have two equal roots. Okay, then I have two equal roots. So this is the standard form which I am talking about. Now let me compare it with the standard form. 2x square minus 7x plus 3 is equal to 0. The standard form talks about ax square plus bx plus c being equal to 0. So b square, what do I have as b? B is equal to minus 7, a being equal to 2, and c being equal to 3. B square is 49 minus 4 is multiplied by 2 multiplied by 3. This means 49 minus 24. 49 minus 24. This is equal to 25. This falls in the second category, which I have mentioned as my second category, and third category according to the snippet which is attached over here. The determinant is greater than 0. It means it has two distinct roots. Okay. The formula which we are going to find out, which we are going to use for x, or to find out the root, is this. The value of x is equal to minus b plus minus root of b square minus 4ac whole upon 2a. What does minus b stand for? Minus b stands for 7. What about plus and minus? It means one solution would be positive, the other solution should be negative. Or in one solution you have to use the positive formula, in the other solution you have to use the negative formula. Or 7 plus minus, we have the determinant as 25. When I take the determinant in root, it becomes 5. So 7 plus minus 5 upon 2a. 2a stands for the alphabet a, or the coefficient of x square, which is 2 into 2, which is equal to 4. So when I have 7 plus 5, it makes it 12 by 4. When I have 7 minus 5, it becomes 2 by 4. When it becomes 12 by 4, it becomes 3. When I have 2 by 4, it becomes half. So these are the two distinct roots which are real in nature and which are existing. Okay. So this is how I solve my question. I'll move to the next point. Yep. So what do I have here? I have here that a by L plus m by b is equal to 1. B by m plus n by c is also equal to 1. So I need to find out the value of L by a plus c by n. All the options which I have over here, these will not let you reach the exact answer. Okay. Had there been numerical options, it would have been easier. But now I am stuck. I am heavily stuck between the variables and the numbers. So this question requires a lot of mental stamina. So I'll help you understand how it works. Just see that the value of a by L and the value of n by b is something which is adding up to 1. Whenever I have something adding up to 1, I have to assume a few things. Is there something which adds up to 1, which is positive in nature and is also in the form of p by q, or is also in the form of a fraction? The answer is yes. If I add up 1 by 5 plus 4 by 5, I would get the value as 5 by 5, and this answer would be 1. But this is a little complicated. Let me take it simply as half plus half. When I say half plus half, I tend to ease down my entire question. So when I say half plus half is equal to 1, so you're able to understand it better. That means the value of a is 1, the value of L is 2, the value of m is 1, and the value of b is 2. When I apply it back over here, this tells me 2 upon 1, because the value of b and m have been set and they have been assumed very well. So this says 2 upon 1 plus something is also going to be 1. Now this is the problem. I already have a number with me which is bigger than 1, and I need to make it 1. That means we have to subtract something out of it. The subtraction is only and only possible when b by m, there is a minus sign over here. The minus can occur because of n or because of c, and there is a definitive 1 upon 1 over here, because 2 minus 1 is equal to 1. So this is what I am supposed to achieve. Okay, this is what I am supposed to achieve. I already have 2, which is b and m is very constant. I need to assume that n by c is equal to minus 1 upon 1. Okay, this is my assumption that n by c is equal to minus 1 upon 1. If n by c is 1 upon 1 minus 1 upon 1, this means c upon n is also equal to minus 1 upon 1. The reciprocal of a negative of a negative unity is also a negative unity, be it in a fraction form. This is in a fraction form. So I can say that L upon A plus C upon N is what I'm looking for. L upon A plus C upon A is what I'm looking for. So L, what does L upon A stand for? L upon A stands for 2 upon 1. L upon A stands for 2 upon 1. Plus, what does C by N stand for? C by N stands for a negative 1 upon 1. So this gives me my answer as a positive 1. Okay. This gives me the answer as a positive 1. A positive 1. So if I check the value of b upon m, which I have assumed, this comes out to be 2 by 1. If I check the value of m upon b, this comes out to be 1 by 2. The only constant value which I have over here is that of 1. So when I said that you cannot guess the answer, you cannot go a step ahead, that is when I was trying to tell you that always try to follow or put in some logic of your own. This is a logic that was created for you to understand, to create the value of 1, and you have two variables with you. Always use 1 by 2 and 1 by 2. Let's assume you had three variables. You could have chosen 1 by 3, 1 by 3, and 1 by 3 thrice. Okay, so this is how you create the value of 1 when you have two variables in question. This was one of the toughest things that you had to learn, and I have delivered it to you. Okay, let's move on. Now we'll be talking about identities. Okay, I won't be teaching you all the identities at one go. I would be teaching you them in a phased manner. Okay, so first let's quickly come down to the most basic identities of a plus b whole square, and the second basic identity of a minus b whole square. There is also another identity of a square minus b square, which would be subsequently coming up, but I would solve that for you as well. When sum of a and b is multiplied with the when the sum of a and b is multiplied with the subtraction of, or the difference of a and b, that is when a square minus b square arises. For a minus b, I get a square plus b square minus 2ab. Similarly, for a plus b whole square, I get a square plus b square plus 2ab. Okay, these are the most basic and the standard identities we'll be talking about, and this is what we'll be using in the upcoming questions. Yep. The simplified form of this is what? I'll quickly write I'll quickly write it down in the format, in the like in a manner when we do long division sums or the long addition sums. Okay, I'll be writing it out in that manner so that the calculations become easier, and it is easier to identify that what cancels with what. So when I say 2x square plus when I say 2x plus 3y whole square and 2x minus 3y whole square, I mean to say is 2x plus 3y whole square, and there is a quick sum operation here, and 2x minus 3y whole square. Okay, I need to find out the answer of this. I'll expand it here. 4x square plus 9y square plus 2 3 is 6, 6 2 is 12, 12xy, 2ab, right? 2ab. Similarly, 4x square plus 9y square minus 12xy. Okay, so this is what we get. 4x square in positive, and this is what we are supposed to add up. When I check, when I see and when I check, these two things get cancelled out. All I am left behind with is 8x square plus 18y square. 8x square plus 18y square. So this is the simplified form of the question that was given to us. Okay, let's move on. I have the value 5x plus y is equal to 12 and xy is equal to 8. Now I need to find out the value of 25x square plus y square whole in root. Okay, as I can see, I need to put only this portion in the root. So I'll quickly square it down. I'll write 5x plus y whole square is equal to 12 square. So this is 25x square plus y square plus nxy is equal to 144. From here, I'll pick up the value of xy and put it in. This makes it 80. This is 25x square plus y square plus 80 being equal to 144. The 80 goes here and this becomes 64. 25x square plus y square is equal to 64. Now there is supposed to be a root on both sides because that is the demand of the question. And from the root of 64, I can say that the root of 64 is equal to 8. And this is my final answer. Okay, good enough. I hope you're able to understand very well. Okay, let's move on. I think it's a similar question. Yeah, a little bit. I'll quickly square things on both sides. I would quickly write that 4x square plus 25y square plus 40xy. Okay, I'm just squaring things. I'm squaring the first equation is equal to 225. This is the question that I'm looking for. This is the question that we are looking for. There is a component of xy involved. 40 multiplied by 6 becomes 240. This 240 is a plus sign over here and there is a 225 over here. 2 5s are 10 and no, this is a 20. This is not a 40. This is a 20. Okay, this is a 20. So this is not 240, this is 120. The 120 goes to the other end and it becomes 105. So the value of 4x square plus 25y square is equal to 105. Okay, so this is equal to 105. I hope you're able to understand. I hope you're able to follow. I'll move to the next question. 3 4 slides back, I told you about this identity of a plus b when being multiplied with a minus b, it gives you a square minus b square. Now I will be implementing it in the question. Okay, so this is how we go about it. If 25y square minus x is equal to 5y plus 3 by 2 and 5y minus 3 by 2, then the value of x is what? So I'll first break things down here. There is a missing square sign over here, if I'm not wrong. Yeah, I'll first of all, I'll multiply the two together. A plus b and a minus b. This is the identity that I can see over here. The value of that would be equal to a square minus b square. If I reach that, I would achieve 25y square minus 9 by 4. 25y square minus 9 by 4. This is equal to 25y square. No, I don't think there is an x missing. It's okay. They're just asking me the value of x. They're just asking me the value of x. I can give that straight away, which is minus x. 25y square minus x. So as these two equations need to be compared, I can quickly say that the 25y square is going to get cancelled out. The minus also gets cancelled out. So the value of x comes out to be 9 by 4. The value of x comes out to be 9 by 4. Right? Good enough? Let's move on. Okay. So what do we have over here? They're asking me the value of x and there is an equation which is already given to us. It says that 1 upon x square plus a square is equal to x square minus a square. From this equation, I need to find out the value of a square. So what do I do about it? I can see that these are two terms a and b, and this is also two. These are also two terms a and b. There is a plus sign here. There is a minus sign here. When I multiply them together, I achieve x. I achieve a square minus b square. So the value of 1 is equal to x square plus a square and x square minus a square. A plus b, a minus b. So this would lead me to x4 or x to the power 4 minus a to the power 4 being equal to 1. I can rewrite it as x raised to the power 4 is equal to 1 plus a raised to the power 4. Had it been asking me to find out the value of x raised to the power 4, I could have given this answer. But it has asked me for the value of x. So 1 plus a raised to the power 4 in the root of 4, or 1 plus a raised to the power 4 whole raised to the power 1 by 4. Okay. So the answer that I'm looking for is the first answer, which is this. Right? Happy? Understood? Let me move on. The algebraic expression, this long expression, is equal to what? So you will definitely find such questions in the examination as well. And from there, you will have to derive the answer. Hmm. There is no term of xy which is surviving. Okay, let me try to solve it in my way. Let me trigger the options first. Okay, the options first. If I do that, I get 4x square minus 2xy, 4x square minus 2xy plus 6x plus 2xy minus y square minus 9 minus 3y. Yeah, there is a better way of solving it. Just a moment. So we were doing this particular question. Here, we need to find out the expanded form of all the options and try to match it with whatever is written in the question. Okay, we need to find out the expanded form of all the options and try to match it with the question. So what do we actually have here? We have an algebraic expression. It says 4x square minus y square plus 6y minus 9. So in any of the formulas, wherever you have a perfect square written, it's difficult to find out, or it's impossible to find out any term which would have which would be a square and it would also have a negative sign with it. Okay, you won't find terms which have the degree 2 and a negative sign. The reason is, every time you square anything which has a negative sign in it on the inside, once it squares up, it would not have any it would not have any negative sign anymore. So these two options are straight away gone because it says minus y square. Also, if you multiply these two brackets, you tend to see that the minus and the minus would automatically get plus. But the coefficient of y square is not plus 1, it is minus 1. So this equation is also not for us. The only option left is this one. Why would I choose this one? Because it has a plus y and a minus y. So every time I'll multiply a plus y with a minus y, I'm going to get a minus y square, which matches my algebraic expression. Each and every question in SSC is not supposed to be solved with a complete with a complete sense. What you can actually do is you can always take the help of the options. Okay, so this question was meant to be put in just for you to know how to solve things with the help of options. Okay, we'll move on. Now we'll be following a better or a bigger formula which has three variables. The three variables are a plus b plus c whole square being equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, so it is this form of expansion. Any term, if it has a negative sign, you have to very clearly see whether it is along with the square portion or is it along with the coupling portion. With the coupling portion, the negative sign will come. With the square portion, the negative sign would not come. Okay, you'll get to understand it once you learn all the expanded forms. Okay, let me move on and use this. Okay, so it's asking me to factorize this entire sequence. What all can I see from it? I can see 4x square, I can see y square, and I can see z square. So these are the variables which have the power of 2 or which have the exponent as 2. So first of all, I would need to put all of them down into their simpler forms, into their rooted forms. So the square of 2x would become 4x square. That is why the root of 4x square is equal to 2x. The root of y square would be y, and the root of z square would be z. So I have all these three variables with me. I have my complete variable available. Now, talking about the signs. Every time there is an xy and a yz, the sign turns out to be negative. But whenever there is an xz, the sign turns out to be positive. That means either both x and z are negatively signed or both of them are positively signed. But if I talk about the common sign which might be making all the difference or which might be creating the negative sign is the variable y. If I have a negative sign over here in y and let all the others remain positive, then when I have a couple of these two, the effective sign is going to be negative. When I have a couple of y and z, the effective sign is again going to be negative. But when I have a couple of x and z, then the couple sign would be positive. So this suits my answer. Okay, so this suits my answer. My answer is going to be 2x, y, and z with a negative sign being only with y and this being a positive sign. I've given the braces and I've given a square. Okay, so I believe my work over here is done, and this is the factorization of this particular question. There might be a position where they might ask you give the exact factors of it. So the exact factors of it is are going to be 12x minus y plus z multiplied by 2x minus y plus z. I might have said 12. I'm sorry for that. Okay, so these two, when they are multiplied with each other, so these are the two factors of this entire algebraic equation, right? Let's move on. Okay, I need to simplify these two. This is a three variable square form. We've learned the formula of it. This is a three variable square form. We've learned the formula of it. What we need to do is we need to write them upside down, or rather than calling it side by side, up and down. Okay. By that, we'll be able to figure out the actual signs of each one of them. And then we would be able to cancel things off. Okay. So I'll quickly expand the first equation. The first equation would be expanded as 4a square plus 9b square plus c square. Okay, it's plus 2ab, which becomes minus 12ab plus 6bc. Yeah, and another plus or a negative. Yeah, a negative 4ac. Okay, so this is the first form. Talking about the second form, you have to remember one thing. The second form is having a negative with it. Okay, so all the signs are going to flip. I would not be placing any sign. I would first be writing all the variables, all the terms in one form, and then I'll be putting the flipped signs. Okay, so it's going to be a square, 4b square, c square, 4ab, 4bc, and 2ca. Okay, so all of them are supposed to have a positive sign. Why? Because they have a positive sign between each one of them. But because of a negative sign on the outside, all of them are going to get a negative sign. Okay, all the signs are going to be flipped and all of them would become negative. Now this entire equation is basically part of the same equation, right? So I'll try to figure out the like terms together. The coefficients of a square, 4 minus 1 is 3, 3a square. I'm getting the answers straight away. Okay, I am getting the answers. I'm on the right track. 9 minus 4 is 5, and that 2 up plus 5 b square. And then the c square term is going to vanish because one is positive, the other is negative. Then I would have a minus 16ab. Okay, so one of the answers is gone. Then I would have a plus 2 bc. Okay, I would have a plus 2 bc. There is no bc here. There are two things over here. And then I would have a minus 6 ac. Okay, a minus 6 ac. So this is my answer. 3a square plus 5b square minus 16ab plus 2bc minus 6ac or 6ca. Okay, are you able to understand how easy these questions are? Okay, I'll move ahead. Now we'll be talking about a plus b whole cube format. A plus b can be expressed in terms of their whole cubes by using a cube plus b cube plus 3a square b plus 3ab square. This is the simplest form. Just a little complex form would be a cube plus b cube plus 3ab multiplied by a plus b. We're doing nothing, we're just taking 3ab common outside. Okay, so this is the form that we've talked about. There's also another way of solving it. The other way of solving it is if I write a plus b whole cube being equal to a cube plus b cube plus 3ab in the bracket a plus b. I can also write a plus b whole cube minus 3ab a plus b being equal to a cube plus b cube. Okay, I hope you're able to understand how this form came out to be. But when I place things in the bracket of a minus b being a cube, it comes out to be a cube minus b cube minus 3ab and in the bracket a minus b. Okay, all the consecutive signs, all the signs except that of a would flip themselves to negative. Okay, I hope everybody is able to understand what I'm talking about. I'll move to the questions now. Okay, I'll move to the questions now. Okay, what is the coefficient of x square in the expansion of this question? Okay, so let me quickly expand it. Do we have a chance of taking anything out in common? I don't believe so. Okay, so I'll quickly solve it. The formula that I'm going to use is going to be a minus b whole cube. The formula is going to be a cube minus b cube minus 3ab in the bracket a minus b. Okay, so here we go. Yeah, 3 root 3 x raised to the power 6 minus 343 into 2 root 2, yeah, minus 3 into root 3x square multiplied by 7 root 2 multiplied by root 3 x square minus 7 root 2. So it's asking me the coefficient of x square. So if I leave these things behind, if I leave out these things behind, it would not make much of a difference. Okay, it would not make much of a difference. The only term which I'm supposed to solve is going to be somewhere here. Okay, and that too, if only I solve this portion along with this portion, I would get the coefficient of x square. Why is it so? Because this x square, when multiplied by x square, would reach the power of 4. But here I would be remaining in the limits of my question, which is asking me to tell the coefficient of x square. So I would multiply minus, this is going to be minus 21 root 6 x square. This would be multiplied by minus 7 root 2. This would be multiplied by minus 7 root 2. The negative and the negative would cancel itself out to become a positive. Then with a 21, no, with a 7 multiplied by 21, it would become a positive 147. It would become a positive 147 root 12 x square, or I could take a 2 out and leave a 3 behind, and this would become 2 sevens are 14, 2 fours are 8, 9, 2 ones are 2. This would become a 294 root 3 x square, which would be the coefficient of x square in the problem. You could have solved the entire question like I did, but if you could foresee where the x square would land up, which I could see after writing down the expanded form, you would still be in a good position to solve this question in about 90 seconds. Not under 60, but definitely 90. Okay, and it's okay to solve a few questions in a longer way. Okay, it's completely fine to solve a few questions in a longer way. All right, let's go. Yeah, so I have another question with me. If x plus 3y is equal to 6, what is the value of x cube plus 27y cube plus 54xy? What can be done? I believe I should use a simple cubing formula, x plus 3y being equal to 6, and I should cube both the sides. Yeah, I should cube both the sides. When I do that, I get an x cube plus 27y cube plus a 9xy multiplied by x plus 3y being equal to 216, which is the cube of 6, right? Yeah, that's the cube of 6. So what is it asking me? It's asking me to have a form of x cube, 27y cube, and 54xy. Here, I cannot see the value 54xy being present anywhere. But if I take a closer look, I can see that x plus 3y already has a value of 6 in the question. X plus 3y already has a value of 6 in the question. When this situation comes up, I can substitute the value. 9xy could be multiplied by x plus 3y, which would ultimately become 6, and 6 nines are 54. 6 nines are 54. 54xy being equal to 216. This is x cube plus 27y cube plus 54xy, which is exactly as the question was supposed to be. And 216 is going to be my final answer. Okay, I hope everybody is comfortable with it. I'll quickly move on. Now, there are situations when these two questions become very useful for us. These two formulas become very useful to us. Whenever you see any formula talking about x cube plus y cube, you must remember it becomes x plus y multiplied by x square plus y square minus xy. Similarly, x cube minus y cube comes down to be x minus y multiplied by x square plus y square plus xy. Okay, there are a little more complex forms as well, which might be useful in the future. The complex forms are x cube plus y cube. These are not actually complex forms, but people, well, like I tend to call it complex because it has lesser use in the real world questions. X plus y whole square minus 3xy. And when I talk about x cube minus y cube, I tend to get x minus y, x minus y whole square plus 3xy. Okay, so I hope everything is in place and we are in a good position. Okay, let's move ahead. Okay, if a cube minus b cube has been given as 729 and a minus b has been given as 27, then find the value of a square, a minus b whole square plus 3ab. Okay, I'll quickly first write down the formula that we've been taught. A cube minus b cube is equal to a minus b multiplied by, I'll recheck it from here. Yeah, I'll recheck it from here. This is going to be a minus b whole square plus 3ab. Okay, this is how direct formula based questions come up. Had you not remembered this formula, which for which I called them to be a complex formula, if you couldn't have remembered this, you would have to go down to the level where you would have had to find the value of AB alone as well. So that would have made problems a little worse for you. So it's better that you quickly now start placing values in place. 729 is equal to a minus b, which is 27. And the question is asking us the value of a minus b whole square plus 3ab. I'll start using this. This is 9 3s are 27. This is 981s are. This is 3 1s are. This is 327s are. So the value which I've been looking for, a minus b whole square plus 3ab, is nothing but 27. Okay, it's nothing but 27. I hope you're able to identify with what I'm talking about. Okay, good enough. Let's move on. If a plus b is equal to 10 and ab is equal to 6, then find the value of a cube plus b cube. So what I'll do here is I'll write down a cube plus b cube being equal to a plus b multiplied by, I'll quickly look at the formula which we used. Yep, a plus b whole square minus 3ab. Okay, minus 3ab. So I need to find out the value of things on the left hand side. For everything on the right hand side, I have the values in the question. This is 10 multiplied by 10 square, which is 100, minus 3 times AB, which is 6. So 3 6 are 18. This is 82, and the answer would come out to be 820. Simple enough? Okay, let's go. Now, talking about a cube plus b cube plus c cube formula, which can be expanded into multiple forms. Okay, so the first form would be a cube plus b cube plus c cube minus 3abc being equal to a plus b plus c multiplied by multiplied by multiplied by a square plus b square plus c square minus ab minus bc minus ca. Okay, so this entire expanded form is here in front of you. This thing is also equal to half a plus b plus c multiplied by a minus b square plus b minus c square plus c minus a square. Okay, so that game and this entire situation is in place. Coming back, this again is equal to a plus b plus c being multiplied by a plus b plus c whole square. We've already seen this formula in its elongated form, subtracted by minus 3ab plus bc plus ca. Okay, so I hope everything is in place and you're able to understand the entire situation. There can be cases, there definitely can be cases when you'd be like, the same question would come up and in a jumbled form. The same question would come up in a jumbled form, and only at that time, this is the most difficult formula which you might have to learn. So you'd have to just memorize it. Okay, just memorize it. There's no way out of this. Also, in this situation, if the value of a plus b plus c is equal to 0, then you can easily say that a cube plus b cube plus c cube minus 3abc is equal to 0. That also brings you to the position where a cube plus b cube plus c cube is equal to 3abc. Okay, if a, b and c are positive integers, then a is equal to b is equal to c. And if a, b and c are distinct numbers, then two numbers are not equal at a time. That is for sure. Okay, two numbers cannot be equal at that time. Also, if this form of the question is equal to 0, that a square plus b square plus c square minus ab minus bc minus ca, about which we are talking about here. Just a second, I'll mark it. Yeah, we are talking about this portion of the equation here. So when you put this entire situation also being equal to 0, then you ultimately reach a point where a square plus b square plus c square is equal to ab plus bc plus ca, where the precondition or the post condition comes out to be a being equal to b being equal to c. Okay, this is the most complex part, and definitely a good number of questions come from here as well. Let's move on. If x is equal to 5, y is equal to 7, and z is equal to minus 12, then find the value of x cube plus y cube plus z cube. Now, first of all, I can easily say that x plus y plus z is equal to 0. At the face of it, 5 plus 7 is 12, and 12 minus 12 is equal to 0. So this comes out to be 0. But if you look at the formulas over here, they say that when a plus b plus c is equal to 0, then a cube plus b cube plus c cube is going to be equal to 3 times of abc. Okay, it's going to be 3 times of abc. What we are going to do is we are also going to do it really, and we would also be able to do it with the help of formulas. The formula says that when a cube plus b cube plus c cube would be equal to 3abc, the precondition would be that a plus b plus c is equal to 0. So I just need to do 3abc, 3 into 5 into 7 multiplied by minus 12. This makes it 84, 84 5s are 420, 423s are 1260, 1260. Yeah, this is a negative 1260 which we have reached using the formula. But when I try to solve it using a simple cubing format, the simple cubing format would create 5 into 125, right? 5 cube is equal to 125, 7 cube is equal to 343, and 12 cube I believe is 1728. Let me check it here on the right hand side. I'm trying to solve things in the real exam like situation so that whenever you're also in the same situation, you are able to find your way out. 12 fours are 48, another 4, 12 fours are 48, 52. Yep, this is 1728. I was right. So this would have a negative sign with it because it has been mentioned that z needs to be cubed. Whenever cubing a negative number, the sign would remain there. Okay. So 1728, let me quickly sum these up first. This would become 468. I would write 468 over here. I would get a definite 2 here, another definite 6 here, then this 1260. Yes, I have achieved the answer using both the ways. Okay, I've achieved the answer using both the ways. Let's move on. Okay, if 1 plus m plus n is equal to 0, then I upon mn plus m square upon ni. No, this isn't I, this is L. Okay, this isn't I, this is L. This is also not I, this is L. Let me rearrange it for you. L square upon mn plus m square upon nl plus n square upon lm whole square. The question says if L plus m plus n is equal to 0, then what will be the value of L square plus m square plus n square with their respective opposites being present in the numerator, in the denominator. So to solve this, let me first put things into perspective. If I take a common LCM of everything, I get the LCM as L m n. Okay, this would become L cube plus n cube plus n cube, L cube plus m cube plus n cube. The whole square is going to remain in place. Okay, whenever the precondition of L plus m plus n being equal to 0 is satisfied, at that time the value of L cube plus m cube plus n cube being equal to 3 lmn comes into play. Okay, so 3 lmn being divided by lmn with a square in the place. This would leave me, these two things would get cancelled out, and I would be left with a 3 square, or simply 9. So 9 is my final answer here. Okay, I hope you're able to understand. You were able to understand whatever is going on. Okay, if not, please drop down your comments. We will definitely get back to them. Okay, some concepts which talk about a square plus b square plus c square being equal to 0. I'll be figuring out them for you. Okay, so we'll be continuing our work. We'll be continuing our work on algebra. Okay, so we'll be continuing with the same question. What does the question talk about, or what does the concept talk about? It says that when a square plus b square plus c square is equal to 0, then we'll have to automatically assume that a is equal to 0, b is equal to 0, and c is equal to 0. Why is it so? Why is it so? What is the theory behind it? The thing is that a square can never be a negative number. It cannot be a negative number. Similarly, b square and c square also can never be negative numbers, because anything which is squared, had it been a negative number in its true form, when I square it, the negative number also loses its sign, because when two negatives are multiplied together, the minus gets cancelled out and the square comes out into the real picture. So I hope you're able to understand what I'm talking about here, right? So all the numbers, even though they would be negative, but that would not fulfill my situation. My situation would only be fulfilled when I would assume that all the three numbers are 0, right? So anywhere you see that a square plus b square plus c square is equal to 0, by default automatically assume that a is equal to 0, b is equal to 0, and c is also equal to 0. Now we'll try to factorize this down, and because everything that is here is in the degree of 2, like the degree of this entire polynomial is 2, but the question that is being asked is of degree 1. So that means there must be some factorization which is missing from the equation. So that is my cue, which means that factorization needs to be done. When I factorize this, I write 8x square plus y square minus 12x minus 4xy plus 9 is equal to 0. Now, in such a situation, I see that the coefficient of x square is equal to 8, and 8 is not a perfect square. 8 is not a perfect square. So in such a situation, I will have to split down 8 into something which is a perfect square. Why am I doing it? Because 8 is not a perfect square, and if I root down 8, it comes to 2 root 2, 2 root 2x. Now, this 2 root 2x would have definitely appeared somewhere else as well, or the root 2x, or the value of root 2 would have appeared somewhere else in the equation as well, had it been a direct multiple or had it been a direct coefficient of x square. That means this 8 has to be split into two parts. So I'll be splitting it into two equal parts, which is 4x square plus 4x square plus y square minus 12x minus 4xy plus 9 being equal to 0. Now I can see that there is a 4x here, and there is a 4 there is a 12x here, and there is a 9 here. Okay, so I can get a q of something being a in 2 into a into b. So I have a 2, I have an a which is coming from 4, root 4 is 2, 2 into a into b. What is b that I'm talking about? B is equal to 3, which is the root of 9. So I'm able to figure out one equation out of this entire situation. The equation must be 2x plus 3 or minus 3. It would be minus. Why would it be minus? Because the coefficient of 12x, which is an amalgamation of 2ab, is negative. So 2x minus 3 whole square. 2x minus 3 whole square. Okay, remember this, 2x minus 3 whole square. I'm done with one equation. What about the second equation? The second equation talks about 4x square, y square, and minus 4xy. So this is pretty simple. This means it is 2x. And what about the sign of y? The sign of y is negative. Reason being that there is a minus 2ab situation. So minus y. And how much y? Y is 1y. It's not more than that, because this is an amalgamation of 2 multiplied by 2x multiplied by y. Okay, 2x minus y whole square. 2x minus y whole square. So I have this situation with me. Now, if this entire equation is equal to 0, then I can say that these squares are also equal to 0. How did I land up to this situation? Because here I had learned that the square of a and the square of b and the square of b and square of c, when all of them added up to 0, then individually a, b, and c would also be equal to 0. I'm using the same property here. That means 2x minus 3 is equal to 0. Similarly, 2x minus y is equal to 0. When I say 2x minus 3 is equal to 0, I get the value of x as 3 by 2. And when I write 2x minus y is equal to 0, so I get 2x is equal to y. So this situation, when I use it here, then I get separate values of x and y. The value of x has been established as 3 by 2, and the value of y has been established as 3. Once I put these values back to my equation, which is 16x minus 6y, what do I get? I get a 24 here, minus a 9 here. No, 9 or 18. I get an 18 here. Okay. So 24 minus 18 is equal to 6, which is my answer. Okay. The only difficult part, the only difficult part which you were supposed to analyze was to split down 8x into two of its own kind. Okay. So this is wrong. That 2 root 2 is the root of 8. You should always focus on the point. If you're finding another root anywhere in the equation, then it could be a clue for you. Okay. If you find another root 2 in the entire equation, then it could be a clue for you that 8 has been used directly. But here we couldn't find another root 2. That meant that 8 had to be split down into something which was a square. So 4 plus 4 is equal to 8. So I used 4 in one equation and 4 in the other equation. So that is the beauty of factorization. I hope everybody understood it. I'll move on. Yep. So I have an equation here. I need to find out the value of a, b, and c. So this equation here is a square. I'll bring everything on the left hand side. That would be very convenient for me. A square plus b square plus 49c square plus 18 minus 2b plus 56c minus, no, this is also plus 2a being equal to 0. Now I will have to factorize it down to find out separate values of a, b, and c. Right? So let me quickly try to factorize a. When I find out the couples of a, I get to see that a has been coupled up with 1. How am I sure about it? Because I see 2 is being multiplied by a, and in the equation of a plus b or a minus b whole square, I tend to see it as a square plus b square plus minus 2ab. So the b portion is equal to 1. So I have factorized down anything. I have factorized down the um, I factorized down the alone a or the lonely a or the a with the power 1. Okay, which completes the equation. That means 1 will have to come out of 18. Okay, 1 would have to come out with 18. Now let me do the same thing for b. I can see one b square here and I can see another negative 2b. This negative 2b can be considered 2 into b into minus 1. Why is it minus 1? Because the definition or the negative sign over here in this equation, which is along with 2ab, defines what the sign of b would be or what the sign of the other variable would be. So we have b here and we have another variable here which is minus 1. So these three things are sorted. These two things are sorted. A and b are sorted. Another one would be derived from 18, which is here. Now, talking about c, I can see 79c square. Here I can see 56c. Now, if you look at it really closely, you would see that this is a mixture of two. I am getting a 7c from the source of c square, which is 7c. Now I am also getting a 4 here. I'm also getting a 4 here. That makes it 56. Okay, 7 8s are 56. Now, where is this 4 coming from? This 4 has to be available in a square format as well, which would be equal to 16. So the constant term which I have over here 18, 18 is also available very well. 18 is also available very well in the form of 16 plus 1 plus 1. So I could, as soon as you can split away the constant term, that means you're done with the answer. Now I'll write all of them together so as to help you understand what I was talking about. Okay, let me use a black pen for that, or rather magenta or whatever color this is. I'll write down the equations of A in one place, the equation of B in one place, and the equation of C in one place. What does A stand for? A stands for A square plus 2A, no, A square plus 1 plus 2A. This completes it. Talking about B, I get B square plus 1 again and minus 2B, and I also get C square. C square is 7C whole square plus 4 minus 2 into 7C into 4. What output do I get out of it? The output that I get out of it is A plus 1 whole square, B plus 1 whole square, 7C plus 4 whole square. This is the output that I get. Now, what is the relationship between these three condensed forms of the equation which were present in a bigger equation? The relationship was of simple addition. Okay, there was a relationship of simple addition. So the final answer comes out to be A plus 1 whole square plus B. No, this is not plus 1, this is B minus 1. Just a moment. Hmm. This is B minus 1, B minus 1 whole square plus 7C plus 4. Yeah, is it 7C plus 4? It's plus 16. Why did I write 4 here? This is a plus 16 here. So 7C plus 4 square. So I have everything in place right now. Is it going to be a plus or a minus? Let me see that. It's going to be a plus only. So yes, we are in the right place. So the question being asked is, this entire equation is equal to 0. Okay. This entire equation is equal to 0, which I picked up from here. So what am I actually looking for now? I'm actually looking for the values of A plus B minus 7C. I'm looking for the values of A plus B minus 7C, which would give me a final solution. Taking you back to the same place where I said anything square plus anything square plus anything square is equal to 0, then you have to assume that all of them are equal to 0. So I will assume that these three separately are equal to 0, which would lead me to the conclusion that A is equal to minus 1, B is equal to 1, and C or 7C is equal to minus 4. Okay, so I'll quickly work on it. It means minus 1 plus 1 plus 4. This gives me a final answer as 4, and I am good to go. Okay. Okay. The only difficult part that you could face over here was to find out the bits and pieces of every variable which are scattered across the equation. Okay. Finding out the bits and pieces of the equation which are scattered across the equation. Bits and pieces of the variables, not the equation. Okay. Bits and pieces of the variables. Let's move on. Okay. So this is the favorite of SSC, and this has been the favorite of SSC for multiple years, for years immemorial. So I would write down the equation straight away. There is not much explaining. X plus 1 by x, if this is equal to A, then x square plus 1 by x square, x cube plus 1 by x cube, x4 plus 1 by x4, and x5 plus 1 by x5. These are the most standard forms. You can easily derive the higher powers using this work. Okay, so I'll quickly write it down. Simple, a square minus 2. Simply going ahead, a cube minus 3a. Again, going ahead, a square minus 2 whole square minus 2, a cube minus 3a multiplied by a square minus 2 minus a. Okay, these are the toughest forms of it. And if you'd like to do them manually, then you can definitely square both sides. X square plus 1 by x square plus 2ab, which is equal to a square. Then you can say that x square plus 1 upon x square is equal to a square minus 2. Okay, which is equal to a square minus 2. I hope you are able to understand whatever I've talked about very well. Right? I hope you're able to understand whatever I have talked about very well. Now, these are the formulas which you must learn by heart. These are the formulas which you must learn by heart. And whenever there is a situation when x is written in a plus form and you are asked to convert it to a minus form, at that point, what you would do is you would square both sides, x square plus 1 by x square plus 2 being equal to a. Now, to convert the left hand side, if I square this side, it says x square plus 1 by x square minus 2. I have to convert this into minus 2, and this is a square. I have to convert this entire equation into minus 2 form, so I would do a minus 4 on both sides. This would reach a square minus 4, and when I put another root on it, I get my x minus 1 by x situation. Okay, x minus 1 by x situation very, very clearly. So, this is how I work things out. Okay, I hope everybody is able to understand. Also, there is another short trick. Whenever you get x plus 1 by x is equal to a, and they ask you what is the value of x cube minus 1 by x cube, at that time you can flip the signs. You can say that a cube plus 3a would be my answer. Okay, if x plus 1 by x is equal to a, then whatever whatever multiple or whatever x plus 1 by x forms you have, and they ask you something in the form of x minus 1 by x or x raised to the power n minus 1 upon x raised to the power n, at that time you can flip the sign and you can get the same answer. Okay, but I would still recommend you to take it slow, to follow the longer method whenever you get a flipping of signs. Whenever the question says x plus and you have to answer in the terms of x minus, okay? At that time, tread a little carefully. It will be good for you. Okay, let me move on. Okay, the question says x raised to the power 4 plus 1 upon x raised to the power 4 is equal to 1442. Then I have to find out what is the value of x minus 1 by x. So what I'll quickly do here is I will add 4 on both sides. I'll add 2 on both sides so that I'm able to reach a conclusion, which is 2 here and 1 triple 4 here. Now, what is the square root of 1 triple 4? This is a very interesting part. If you need to get the square root of 1 triple 4, you have to consider the last digit, which is equal to 4. Also, you have to you have to figure out in your mind what could be the number which is close to 1400 in terms of squaring. When I talk about 30 square, I reach 900. When I talk about 40 square, I reach 1600. So I need to find out a square which is closer to 40 so as to reach my valuable answer. So if I get 39 square, there would be a 1 in the end. If I talk about 38 square, I would definitely get a 4 in the end. So I already know that this is definitely 38 square, but for you, for starters, I would tell you to do a double check. How would I do a double check? I would quickly form my short trick that 8 square is equal to 64, 3 square is equal to 09. 3 8s are 24. 24 2s are 48. So this would come out as 480. This is 4. This is 4. This is another 14. And 1444 is the square of 38. So I have reached 38 here. And x square plus 1 upon x square is equal to 38. Now, I need to reach a point where I can talk about x minus 1 by x. If I try to expand this form, this would come out to be x square plus 1 by x square minus 2. Minus 2ab minus 2. So I need to have a minus 2 on both sides. So I'll do a minus 2 on both sides. I would reach x square plus 1 by x square minus 2 is equal to 36. Okay, this is equal to 36. When I say x square plus 1 by x square minus 2 is equal to 36, what do I actually mean by that? I mean to say when I take root of both the sides, I get into a situation where I can say x minus 1 by 6 x is equal to 6, which is my final call, which is my final answer. Okay, good enough. Let's move ahead. Okay, again, another question. I have the value of 2 root 5 with me, which can also be written as a square minus 2. Okay, I'm writing it as a square minus 2. Okay, the question is find the value of x raised to the power 4 plus 1 by x raised to the power 4. What should I do? I could follow this format. I could follow this format which says that a square minus 2 whole square minus 2 would be my result. Would be my result. What is the value of a square minus 2? Sorry, what is the result of a square minus 2? A square minus 2 is equal to 2 root 5. What about this entire situation being a whole square? That means 4 5s are 20. And another 20 minus 2, which is here from the same equation. My answer comes out to be 18. Okay, this is a shortcut. This is the same formula which I used there. But if you were in my situation, I would recommend you to follow truce, follow the same method. Just simply square on both sides. That would make it x4 plus 1 upon x4 plus 2 being equal to 20. Then you could say x4 plus 1 by x4 is equal to 18. Okay, this is the shorter method. Might look a little complicated, but it is necessary for you to know the shortcuts as well. And this long cut was definitely a shorter way of solving it. Okay, so we are here. Let's move ahead. X plus 1 by x is equal to a, it is given, and we need to find out x cube plus 1 by x cube. We've already talked about a cube minus 3a. Okay, we've already talked about a cube minus 3a. And when there is a situation of x minus 1 by x and we have to convert it to x cube minus 1 by x cube, then a cube plus 3a. Okay, a cube plus 3a. This over here I'll have to make the necessary amends. Okay, this is a minus sign. This is the minus sign where you have to flip the equation. Okay, where you have to flip the sign. I'm back to the same question. Okay, the question talks about a minus 1 upon a minus 2 is equal to 8. Then find out the value of a minus 2 whole cube minus 1 upon a minus 2 whole cube. So the x which we talk about, x plus 1 by x, the x plus 1 by x which we talk about. So in every question which has the form of x plus 1 by x, we see that this x is equal to the other x. Here I can see that a minus 1 upon a minus 2. So I need to have an a minus 2 in the numerator side as well. So what would I do? I would take this 8 and take it to the left hand side and use only 2 out of it. So I can say that a minus 2 in a bracket minus 1 upon a minus 2 in a bracket is equal to 6, right? That's equal to 6. Now I have the form x minus 1 by x is equal to a. And the question being asked is x cube minus 1 upon x cube. I have a simple formula for it. The simple formula says that a cube plus 3 times of a. What is a cube? A is 6 and a cube is 216. 6 cube is 216 plus 3 times of a. 3 times of a is um 3 times of 6 is 18. So 216 plus 18, that makes it 234. So 234 is my answer. A cube plus 3a. I hope everybody is okay with it, right? So these questions are very short, considerably short, if you know the right tricks to them. Okay, let me move on. Now talking about this simple question, if the value of y minus 1 by y is equal to 9, then I need to find out the value of y cube minus 1 by y cube. I have y minus 1 by y equal to 9. Now the same formula I'll be applying. A cube plus 3a. A cube I have here is 9 cube plus 3 times of 9. 3 nines are 27 and 9 cube is 729. So anything with a 6 in the end, no, that's not good. I'll take a 6 here, another 5 here, so it is 756. Am I right? Yes, I am. Simple enough. Simple enough. That is the reason I talked to you. That is the reason I taught you about all these significant formulas. Okay. Every time you encounter, the only point which I believe was might not be clear to everybody is, every time you get an equation where x minus 1 by x has been given, which is equal to a, then the same series would be given with the flipped flipped signs. Okay, they would be delivered with the flipped signs. Good enough. Let's move on. Okay, this is good. This is good. This is done. We are done with this. We're done with this. Now, this question. So, when x square plus 1 by x square is equal to a, it is given, and we have to find out the value of x cube plus 1 by x cube. Okay, it's no different. When you remember the old formulas, then everything you'll be able to solve. It says when x square plus 1 by x square is equal to 34, find out x cube plus 1 by x cube. So, I can say that a square minus 2 is equal to 34, and I need to find out the value of a cube minus 3a. Okay, I'll try to find out the value of a first. The value of a square is equal to 36 and the value of a is equal to 6. Now this being established, I'll take it here. A cube means 216 minus 3a means 18, which would give me my answer as 198. Yep, so 198 simply is my answer. I hope we are clear about it. Yes, so let's move on. Okay, so a square plus 1 by a square is equal to 7 by 3. Then what is the value of a cube minus 1 by a cube? So I would follow the simpler method of doing it, that a square plus 1 by a square is equal to a square minus 2. Like a square being the value of minus 2, or let me put it as x square minus 2, where x square minus 2 is equal to 7 upon 3, which is equal to 7 upon 3. So the value of x square would be 2 goes there, and 3 2s are 6. 6 plus 7 is 13 by 3. I find something not going right. A square minus 2. Uh, if I put a minus 2 on both sides, then I will reach that point. So, yeah, there was a small fault. There was a small fault, and let me clear that out. It will be easier for me to solve it that way. Okay, I'll just quickly redo it. I have been told that a square plus 1 upon a square is equal to 7 upon 3. If I reach a point where I can write that the value of a minus 1 by a is available as k, then I can quickly reach my answer as a cube minus 1 upon a cube by saying that k cube plus 3k is going to be my answer. So let me find the value of k first. So if I take a minus 2 on both sides, Okay, this is a minus 2. Then this is 7 by 3 minus 2. So this is how I will reach my value of a minus 1 by a. Let me write it more clearly. I will reach my value of a minus 1 by a minus 1 upon a. This entire situation squared is equal to 1 by 3. When I say a minus 1 by a being equal to 1 upon root 3, being equal to 1 upon root 3, that is when things go better for me. I've now gotten the value of k with me. Okay, this is the value of k that I've gotten. I need to find out the value of this expression which says k cube plus 3k. K cube means 1 upon 3 root 3 plus 3k means 3 upon root 3, right? This means 3 upon root 3. If I take an LCM, I would get 3 root 3 as the LCM and 1 plus 9. This would become 10 upon 3 root 3. This would become 10 upon 3 root 3, which is my final answer. Okay, that is why the questions or the examples or the formulas which I have taught you in the past are very, very important. Right? Let's move ahead again. Um, yeah, this is the derivation of x raised to the power 5 plus 1 by x raised to the power 5. So x square, this thing when multiplied by this thing would leave an extra element of x plus 1 by x. That is why this negative sign had to be brought into the picture. Okay, I'll quickly tell you how this thing works. When I say I need to find out the value of x raised to the power 5 plus 1 by x raised to the power 5, at that time when I have to use two formulas. I have to use the formula of x cube plus 1 by x cube. I have to multiply this situation by x square plus 1 by x square. Okay, I have to multiply them. Now when I multiply them, I get the value of x raised to the power 5. Because this 3 and 2 are getting multiplied, the powers will get added, plus x, because x3 minus x2 would become x1. Okay, plus I would get 1 by x as one term and 1 upon x raised to the power 5 as the other term. So this is basically a byproduct, which is an unwanted byproduct. What would I do with that? I would remove it. Okay, I would remove it. So x raised to the power 5 plus 1 by x raised to the power 5. And when I remove this situation out of the equation, I have to write a minus x plus 1 by x over here. Okay, okay, so this is the derivation. You would face a situation where you would have to find out x raised to the power 7 minus 1 by or plus 1 by x raised to the power 7. At that time you will have to use the formulas of x raised to the power 3 plus 1 by x raised to the power 3 minus the formulas, or sorry, multiplied by x raised to the power 4 plus 1 by x raised to the power 4, right? So you'll have to multiply the two equations. Whatever byproduct is present, you would have to subtract it away from the main equation line. I hope I've made myself very clear. Okay, so I'll be moving on. Okay, so now we have x raised to the power 7 plus 1 by x raised to the power 7. No problem. I'll first create a formula out of it. Then only I'll go ahead. X7 plus 1 by x7. This has to come with x4 plus 1 by x4. This entire situation would be multiplied by x3 plus 1 by x3. The situation is clear. The situation is clear. Now I'll start multiplying them. This becomes x7. This becomes x. This becomes 1 by x. And the final terms which are in the denominator they become 1 raised to the power x raised to 1 by x raised to the power 7. Okay, so what do I get out of it? I get x7 plus 1 by x7 minus or plus the value of x plus 1 by x. Now let me put in the values. Okay, I'll use this thing to go on the minuses side. When I use the formula, I'll change my pen color. When I use the formula of x4 plus 1 upon x4, at that time the, the equation comes out to be, sorry, the equation comes out to be a square minus 2 whole square minus 2. Okay, a square minus 2 whole square minus 2. This entire scene would be multiplied by a cube minus 3a. Okay, and this entire situation would get a negative sign of this value, which is equal to a. In the beginning, I forgot to declare that x plus 1 by x is equal to a, and that is what leads me to this entire drama or this entire big big equation. Okay, so the value of a, which is equal to 4 right now, I'll quickly put it inside. 4 square is 16, 16 minus 2 is 14, 14 square is 196. Yeah, 14 square is 196. Yes, I'm not wrong. 15 square is 225. Yep, 196. 196 minus 2 would be 194. I'm here. Okay, 4. This would be multiplied by a cube minus 3a. A cube stands for 64, minus 3a stands for 12. 64 minus 12 is equal to 52. And there is a component of minus a, which is nothing but minus 4. Okay, I'll quickly multiply 194 with 52. So I'll multiply with 2 first. So 2 fours are 8, 2 nines are 18, 2 ones are 2, 388 multiplied by 50. This is a 0, 5 fours are 20, 5 nines are 45, 47, 5 ones are 5, and 9. 9700. I get 88 and 1000 or 10,088 minus 4. This gives me 1, 0, 10,000, 084 as my answer. Okay, so this is the answer that I was looking for. I hope everybody is happy with the solution, right? Everybody is happy with the solution. Let me move on. Okay, so this is one of the most nasty questions which I've ever seen. I won't say that. So I have something called y minus 1 by y being equal to minus 9. To make it of a power of 5, what I would do, I would call I would call into play the powers of 3 multiplied by the powers of 2 minus the powers of 1. Okay, so what do the powers of 3 say? They say this is also equal to a. They say that a cube plus 3a is in my kitty. Okay, because this is a negative sign question, that is why it would be multiplied by a square minus 2. It would be multiplied by a square minus 2. Talking about minus y. Talking about minus y. What is minus y? Minus y raised to the power 1 means, simply means a. Okay, so I have a with me, which is minus 9. Minus 9 cube stands for minus 729, and minus 27 would be applied here. The same, this thing is going to be multiplied with a square minus 2. A square is 81. 81 minus 2 is 79. Now another minus is required, and that minus would turn itself into plus because it is minus 9. it will turn into plus. Okay, it will turn into plus. Now I have this situation with me where I have a huge value of minus, and how much is it? 4 plus 6. This is 756. 756, that 2 of minus, multiplied by 79 and plus 9 in the end. So this you can take up as homework, because 9 6 are 54, 54 somewhat 3. You just check it on yourself. Check it on your own. Okay, 9 6 are 54. We'll be sitting somewhere at 54, and 54 plus. Uh, it should have, maybe this is the answer. Okay, you check it on your own once, and then we'll talk about it. This is not supposed to be a square minus 2. This is supposed to be a square plus 2. This is supposed to be a square plus 2. Hmm. This is supposed to be a square plus 2. So this wouldn't be 79. It would be 83. It would be 83. This is also 83. But this is 83. Just a second. Yeah, this is 83. Okay. So now I can say that this is 3 6 the 18, and 18 minus 9 would give me a 9 over here. So out of these two, one would be the answer. Would I be able to reach the answer here? It talks about 8 sevens are 56. 8 sevens are 56. So I'm a little higher than that. 56 plus how much more? Hmm, 8 fives are 40. 8 sevens are 56. That is 60. Is it higher than 60? The answer is yes. So yes, this is the answer. C is the definite answer. I'm very sure about it. Okay, so let's move ahead. Okay, so there can be situations when we get that x plus 1 by x is equal to 1. In that situation, the value of x cube comes out to be minus 1. And there can be situations when x plus 1 by x is equal to minus 1. At that time, x cube becomes equal to 1. Okay, you have to remember that. Remember this. Then, talking about x plus 1 by x being equal to root 3, at that time, if you solve it, if you expand it, you'll reach a point where you can say that x raised to the power 6 is equal to minus 1. Okay, x raised to the power 6 is equal to minus 1. Okay, remember these rules. We'll be using them directly in the questions. Okay, it says that x plus 1 by x whole square is equal to 3. So I can declare that x plus 1 by x is equal to root 3. This brings me to the concept which I just learned. If there is a root 3 in the equation, then x raised to the power 6 is equal to minus 1. I'll use my formula that x raised to the power 6, x raised to the power 6 is minus 1, right? X raised to the power 6 is equal to minus 1. So minus 1 raised to the power 18 upon 6 plus minus 1 raised to the power 18, sorry, 12 upon 6. Okay, I'll rub it off for better understanding. Yeah, 12 over 6, because every sixth power is equal to minus 1. So I'll have to divide the powers which are available to me. Plus 1. So minus 1 cube is minus 1. Minus 1 square is plus 1. Another plus 1. So my final answer or my final output comes out to be plus 1. Okay, my final output comes out to be plus 1. Sorted. Let's move ahead. X plus 1 by x is equal to minus 1. Okay, so we've already dealt with it. This means that the value of x cube is equal to, let me go and check it for my own experience, that the value of x cube would be equal to 1. So if the value of x cube is going to be 1 or minus 1, let me check it one more time. value of x cube is going to be 1. So the value of x cube is 1. So I'll quietly put it down that 1 raised to the power 15 upon 3 plus 1 upon 1 raised to the power 15 upon 3. In any case, the answer is going to come out as 1 plus 1. So my answer is 2. Okay. I hope it was easy for everybody. Let me move on. Again, whenever x plus 1 by x is written as 2, then there is only one possibility that x is equal to 1. When it is written as minus 2, this is an x over here. When it is written as minus 2, there is only one possibility that x is equal to minus 1. Right? So this is the question here. If x plus 1 by x is equal to 2, then find the value of x raised to the power 6 plus x4 plus x2 plus 1. All the values are going to come up to be 1 plus 1, 1 raised to the power 6, 1 raised to the power 4, and 1 raised to the power 2 plus 1 raised to the power nothing, 1 raised to the power 1. So this answer is going to come up as 4. Okay, simple. Moving on. Okay, this is a little interesting now. This is a little interesting now because there is no mention of x plus 1 by x. Okay, there is no mention of x plus 1 by x. But if you have a question available with you, if you have a question available with you which talks about, if you have a question available with you which talks about an expression, then you have to find out this expression inside the question and try to put in values. When I say that x plus 2 by x is equal to 1, then I have to strive to create x plus 2 by x somewhere in the question. So I can see that there is x square and I can see that there is 2. I can see there is an x square, I can see there is a 2. If I divide the equation, or if I divide the numerator and the denominator both by x, then I will be able to achieve the question which is already given to me as 1. So the value would come out to be x plus 7 plus 2 by x. This is the numerator. Talking about the denominator, there can be x plus 13 plus 2 by x. The value of x plus 2 by x is or has already been declared as 1. So this is 1 plus 7, which is equal to 8, and this is 1 plus 13, which is equal to 14. Now 2 4s are 8, 2 7s are 14. Okay, 2 4s are 8, 2 7s are 14. So 4 by 7 is something which I am looking at. 4 by 7 is something which I am looking at, which is my final answer. Right? Try to find out the question somewhere in the, or try to find out the equation which you have somewhere in the question and put in the values. You don't have to find out the value of x all the time. Okay, remember this. You don't have to find out the value of x all the time, especially in chapters like algebra. Right? Good to go. Let's go ahead. Simplify by value putting. Some expressions can be simplified by simple value putting. Uh, okay. So there is a concept called componendo and dividendo. I hope people might be familiar with it. When a by b has been given as x by y, then there is a concept of componendo and dividendo where in the numerator I'll add the denominator and in the denominator I'll add the numerator. Okay, both ways. So it will become a plus b. Like in the numerator I'll add both of them and the denominator I'll subtract both of them. Okay, a plus b upon a minus b. I'll do the same thing on the right hand side, that x minus y, sorry, x plus y whole upon x minus y. This keeps the ratio game intact. Okay, always remember this keeps the ratio game intact. This doesn't change any of the ratios. This is also equal to a by b. The ratios are going to remain constant at all times. Got it? Okay, let me move on. Is there something which I have to see here? I don't think so. Yeah, let me check this. I think I should give this question as a homework because this seems to be unsolvable. Is it or is it not? Hmm. 1 plus x. Definitely unsolvable. You should do it on your own and answer about it here. Or towards the end of the class, I'll solve it for you. Okay. If a plus b plus c is equal to 0, then find the value of a square plus b square plus c square whole upon a square minus bc. Now, there was a situation where I said that a square plus b square plus c square is 0. That means that all of them are equal to 0. I cannot apply the same principle over here because there is nothing to support me. Okay, there is no 0 which would be able to support me. What would I do in such a situation? I would assume values which all come out which all sum up to be 0. If I have a, b, and c, I would do a 3, a minus 2, and a minus 1. All of them sum up to be 0, right? So when I say a square, I mean 9. When I say b square, I mean 4. When I say c square, I mean 1. When I say an a square, it's again 9. When I say minus and minus b into c is nothing but 2. So this is 14 upon 7. This gets cancelled out and my final answer comes out to be 2. I need not check it for any other sample. Reason being, no matter how many times I check, the values are not going to be dependent on the variables. Okay, because the answers are all numbers. That is why none of the values or none of the outcomes is going to depend on the variables a, b, and c. Had that been the case, had a, b, and c been used anywhere in the answers, at that time I would have to solve it multiple times to find a pattern. If a plus b plus c being universally 0 helps me or not. Okay, I hope I've made myself very clear that every time you see a plus b plus c equal to 0, use the simplest form. Use the simplest form. You can also go with 2 minus 1 and minus 1. No big deal. Okay, you can go with this, no problem. I'll move on. Okay, so in this question, it says that a raised to the power 4 plus a square b square plus b raised to the power 4 can be split apart as a square plus b square minus ab and a square plus b square plus ab. Is it applicable to the question which we left behind? Uh, is it? Just let me see. A4 plus b4. No, not exactly. Okay, it's just applicable to these two. Hmm. If x4 plus x square y square plus y4 is equal to 27, this is basically made out of x square plus y square plus xy entire situation multiplied by x square plus y square minus xy. Okay, so this is the situation which I have over here. I have 27 with me. I have one of the values with me, which is 9. Now I need to find out the value of k, which is missing. Okay, so this is 9 ones are, this is 9 these are. So I have the value of k, which is equal to 3. Now I have two equations which are very similar in nature. That would help me find out the value. That would help me find out the value of xy. Okay, let me try and do that first. So what am I going to do here? I'm going to write x square plus y square plus xy. Okay, this is the question that we were discussing. In this particular question, what are we supposed to do? We have bigger equation x raised to the power 4 y raised to the power 4 plus x square y square. We've just learned about this equation here, that the bigger equation is equal to a square plus b square minus ab once and plus ab the other time. So we'll be doing the same thing here. We have the big equation x4 plus y4 plus x square y square being equal to 27. this big equation is going to split up in two parts, which is x square plus y square minus xy and x square plus y square plus xy. The plus equation has already been given as 9, so it is going to be a product of it. Okay, so these two when get multiplied become 27. So 9 has to be multiplied by 3 to make it 27. Then the value of 1 by x square plus 1 by y square is what? Okay, so this is the question. So I have two equations uh, about which I'm absolutely sure that what values are going to come up. So with x square plus y square minus xy being equal to 3 and x square plus y square plus xy being equal to 9, I can I can easily add things up. Okay, I'll quickly add. When I add it up, I get the value of x square plus y square. There is a 2 involved as well, which 9 plus 3 is 12. 12 by 2 is 6. Okay, so x square plus y square is equal to 6. If I subtract the two equations, then I get the value of xy, and the value of xy is going to be 9 minus 3 is 6. 6 by 2 is 3. So the question says I need to get the value of 1 by x square plus 1 by y square. That can be possible if I have x square plus y square and the entire situation is divided by x square and y square. Okay, so I'll have to square this situation. I'll have to square this small equation. The equation once squared comes out to be 9. So the value of x square is 6. The value of x square y square is equal to 9. So the value would be 2 by 3. Okay, the value would be 2 by 3. I hope that is what everybody was looking for. Now we have another question here. The question is pretty difficult to solve if you see it at once, but if you go back and check your basics, we are right at point. Okay, we are right at point. The only problem is that x has a power of 4 and y has a power of 4. Whenever things go towards the power of 4s and 6s, it's then when it's that time when we suffer the most. So instead of considering them to be the powers of 4, let's put them as x square being equal to a and y square being equal to b. Now, if I say that a square plus b square is equal to ab, does it ring a bell in the bigger formula of a cube minus b cube or a cube plus b cube? Let me do that here and let me help you understand a square plus b square minus ab being equal to 0. If I multiply a plus b on both sides, the 0 will self-absorb it. This 0 will not let it sustain. Okay, so this entire situation is equal to 0. But if I want to like compress it down into its previous version, then I can say this is the formula of a cube plus b cube being equal to 0. But here I had already assumed that the value of x square is equal to a and the value of y square is equal to b. I had already assumed that. So the value of a cube would be equal to the value of x raised to the power 6 plus the value of b cube would be equal to y raised to the power 6, and this entire thing would be equal to 0. So my final answer is 0. Okay. There was one question which I deliberately left behind by telling you to solve it on your own. So this is the question we were talking about. So here we have to calculate for x square, y square and 4xy. Let me square it on both sides and reach a place where I can specify things. Okay, this is 4 upon 5. Now, even if I try to multiply it, it is going to give me a very gloomy picture, and we would not be able to reach this sort of an identity. Why? Because the question that it's asking for us to calculate, this is not part of any identity. Okay, so we will not be able to reach it. So in such a situation, it's very safe for you to assume the values of any variable to be equal to 0. Okay, Why are we taking the value of any variable to be 0? Because in the answer or in the question which is being asked, if I assume that x is equal to 0, my y will definitely survive and give a positive answer. If I assume my y to be equal to 0, then my x will survive and still give me some answer. Okay, so it's safe for us to assume that the value of x is equal to 0. When I say that, the 1 stays in one bracket. 1 minus y square is equal to 4 by 5. So this thing is going to change. 1 minus 4 by 5 is equal to y square, and the value of y square is equal to 1 over 5. The value of y square is equal to 1 over 5. So the question asks the same thing. If I now assume that there is an assumption line, here is an assumption line. The assumption line is that x is equal to 0. Okay, the x is equal to 0. When x is equal to 0, this is 0, this is 0. I'm only left with plus y square, which I have to tell. 1 by 5 is my answer. Okay, I hope we're good to go. And this ends our chapter of algebra. The most important points would be here when I talk about all the x plus 1 by x formulas on this page, and also all the other identities which were discussed throughout the day. Okay, so I hope you enjoyed it. Please leave some feedbacks in the comment, and we'll be happy to serve you in the upcoming chapters as well. Okay, thank you.